Okay, here's problem number 2. We have a 50-gallon tank, contains 20 gallons of pure water at the start, okay? So it's not full at all, it's only 40% full. A solution with 0.5 pounds of salt per gallon enters the tank at 4 gallons per minute. A drain allows 2 gallons of solution to exit per minute. So what is the salt content when the tank becomes full? So here's a picture of what's going on. So we have our tank, okay? This is a 50-gallon tank, and right now we have 20 gallons in it to start with. And then we have some solution entering, right? This 0.5 pounds of salt per gallon solution, and we have some solution exiting as well. But we have more entering than exiting at any given point, right? Because our volume rate of entering is 4 gallons per minute, whereas the exiting solution is only 2 gallons per minute. So that means that our volume is going to increase steadily until we get to the top there. Okay, so how can we represent our volume? This is going to be, so our initial volume, when t is 0, we have 20 gallons in the tank. So that's a given. That's a constant here, okay? So even if we have t equals 0, then we'll still have our volume is equal to 20, which is good. And then we have plus, we should add in 4t, because this means per minute we're adding 4 gallons in, right? As given by this entrance rate of solution, and we also have 2 gallons exiting per minute. Okay, so this simplifies to V of t is equal to 20 plus 2t. So this plus 2t just represents like the net growth in volume, or the net change in volume per minute. Okay, so this is our volume here. This is our volume function, and so how are we going to solve for when our tank is full? That would be when our V of t is equal to 50, because that's the maximum capacity of our tank. Alrighty, so this is equal to 50 at what time? And then we'll solve for t. So if we subtract 20 on both sides, we get 30 is equal to 2t. Therefore, t is equal to 15 minutes, and this gives us the time. So this is the time at which, or when, tank becomes full. When tank is full. Alright, so let's just keep this in mind. We'll need it for later on in the problem. Okay, so now let's deal with the salt content, okay? So let's say x of t represents our salt content in the tank at any given time t. Alrighty, so then our dx dt, or our x prime, we could say, is equal to rate in of salt minus the rate out of salt, okay? And again, here's a reminder, our V of t, our volume at any given time, is given by 20 and then plus a 2t. Okay, so when we do this, we have to be pretty careful. So rate in, this is going to be what? So rate in is the volume rate of entrance, so that would be 4 gallons per minute, per 1 minute. Okay, and then times the concentration of the solution entering, and that is 0.5 pounds per 1 gallon, right? That was the given concentration there. So 4 times 0.5, so like 4 times 1/2 basically, is just going to be 2. So 2 pounds per minute. That's the rate of entrance of salt into our tank here. Okay, and then the rate out, let's do that one. So rate out is going to be given by however much of the solution is exiting. So the volume rate of exit is 2 gallons per minute. Remember, that's all that the drain allows to exit in 1 minute. And then our concentration is going to be x of t, so whatever salt is in there, divided by the total volume at any given time. And this is where we have to be careful, because now this function up here represents our total volume at any given time. So we're going to plug in that 20 plus 2t, okay? And this is given in pounds per 1 gallon, or per this many gallons, okay? So the gallons cancel out, and so do the 2's, so we can cancel out 2's everywhere. So we're going to get basically x of t, or just x we could say. So just x, this is equal to x over 10 plus t, and this is pounds per minute. Okay, so ultimately our x prime, our ODE is going to look like this. We have x prime is equal to a 2, and then minus x over 10 plus t. Okay, so this is our ODE that we're going to be dealing with here. Alrighty, let's continue this on the next slide. So now our goal is to solve this ODE. So x prime is equal to 2 minus 1 over 10 plus t times x. I just separated those a little bit. Okay, so our a of t, because we see this is a linear differential equation, a of t is equal to negative 1 over 10 plus t. Okay, So when we rearrange this, we have x prime plus this whole quantity, and I just added that to the left side. Then we're left with a 2 on the right side. Our integrating factor is going to be e raised to the negative at dt, okay, which is equal to e to the, now it's a positive 1 over 10 plus t dt, and this is basically just e to the ln of 10 plus t, and then this simplifies to just 10 plus t, okay? So that's our integrating factor here, so we'll multiply by this 10 plus t on both sides. So if we multiply by 10 plus t, we're going to get, on the left side, we have 10 plus t times x, and then this is all prime, right? And then we have 2 times 10 plus t, okay? So once we have that, we can simplify the right side here. So let's just do that. So we have 20 plus 2t. Okay, so if we integrate with respect to t on both sides, we get the following. We have this 10 plus t times x just comes out, and like pretty much untouched, and then is equal to 20t and plus t squared plus a c. Okay, so now that we have something like this, let's just rearrange a little bit. So we have x of t is equal to, let's say, t squared plus 20t, I just switched those, plus c, and this is all being divided by 10 plus t, okay? So let's just solve for the c. We'll do long division in this case, and I'll do that on the next slide. So we have our, let me write it over here. So x of t is equal to t squared plus 20t plus c over a 10 plus t, or t plus 10, okay? So we have this t squared plus 20t, and then plus c, we'll just write here, okay? So this is t plus 10. So when we do long division, we get t, and then this is t squared plus 10t. We're going to subtract that away. Subtract, subtract. Okay, so those cancel, and we get 10t plus c. So this is equal to, we're going to have a plus 10 up here to equate to that 10t right there, plus 100. And then if we subtract, subtract, okay, so we get minus 100, okay? So we'll have c minus 100. All right, and we want that c to be like 0, okay? Because we really had nothing here else to divide with, or to divide by. So we want our c basically to equal our remainder, which was negative 100, okay? So basically the rest of this thing, so when we write our x of t is going to be this part and this part right here, this divided fine, okay? And this was equal to t plus 10, okay? So we have t plus 10, and our c here, that was really nothing before. It's just a constant, and our remainder turned out to be negative 100. So we want our constant to absorb that remainder. So now we have negative 100 over our 10 plus t, okay? Because that's what you get when you have the remainder of from long division, okay? So now this is our x of t, and then from here, we're going to recall that the time that we are interested in is when t is equal to 15 minutes. And remember, we solved in the very beginning of this problem, this is the time at which our tank becomes full, right? So we wanted to find what is the salt content when our tank becomes full. So this is the time we're using, and we're just going to plug it in to our salt content formula here, which is this thing. Okay, so we're just going to plug in 15 in for all the t's. So we get 15 plus 10 minus 100 over 10 plus 15. So on the bottom we have a 25. Okay, so this is 25. 100 divided by 25 is a 4. So we have 15 plus 10, 25, minus 4, which gives us 21 pounds of salt. Okay, so this is how many pounds of salt are in the tank when our tank is full. Okay, that wraps up the practice problems video for section 2.5 on mixing problems. I hope that helps, and good luck on your homework.